Friction is the resistance to motion of one object moving relative to another. Scientists believe it is a result of the electromagnetic attraction between charged particles into two touching surfaces. Static friction acts between surfaces at rest with respect to each other. The value of static friction varies between 0 and the smallest force needed to start motion. This smallest force required to start motion or to overcome static friction is always greater than the force required to continue the motion or to overcome kinetic friction. With this experiment, the idea is to measure the coefficient of static friction between two surfaces, in our case wood and aluminum foil. And with this, we want to confirm the theory that it is independent from the masses and dependent from the surface. The formula we use is static friction is equal to the tangent of the critical angle.
Variables. Our dependent variable was the angle at which friction stops resisting the weight of the objects in the box. The independent variable was a material that we used between the piece of wood and the box with the weights. In this case, we used aluminum foil. Important concepts and definitions. Friction. Friction is a force resisting the relative motion of solid surfaces, fluid layers, and material elements sliding against each other. Weight. The weight of an object is related to the force acting on the object, either due to gravity or to a reaction force that holds it in place. Protractor. Instrument used to measure the degrees of inclination of a surface. For the first weight, which was the one of 0.2 grams, we started elevating the piece of wood until the object started to fall. It started to fall at an average of 20 degrees each time. This means that at this angle, the force that pulled the object down was greater than the friction force acting on it. For the second weight, which was the one of 0.4 grams, every try started falling at an average of 35 to 40 degrees. And for the third weight, which was the one of 0.6 grams, we found that the average also was 20 degrees.
To obtain the results, we use the formula static friction is equal to the tangent of the critical angle, and then we divide it between the kilograms of the object. The results with the first object were angles between 18 and 20 degrees, which gives us an average critical angle of 19.8 degrees. We obtained the tangent, which is 0.36, and then divided by the kilograms of the object, 0.2. In this case, the static friction of object 1 is equal to 0.0018 newtons. The results with the second object were angles between 28 and 35 degrees, which gives us an average critical angle of 31.3 degrees. We obtained the tangent, which is 0.61, and then divided by the kilograms of the object, 0.4. As a result, the static friction of object 2 is equal to 0.0015 newtons. The results with the third object were angles between 19 and 21 degrees, which gives us an average critical angle of 19.8 degrees. We obtained the tangent, which was 0.36, and then divided by the kilograms of the object, 0.6. Subsequently, the static friction of object 3 is equal to 0.006 newtons.
In conclusion, the aluminum foil slides on the ramp due to the inclination and friction created when the foil slides. This theory is independent to the masses, but it still depends on its mass. On the results, the degree of the angle increased as the weight of the used object increased, and we can say that the friction of the object increases as the weight does.